Okay, so we're going to look at problem 9.2.22. It says, according to an exit poll for an election, 55.4% of the sample size of 813 reported voting for a specific candidate. Is this enough evidence to predict who won? Test the population proportion who voted for this candidate was 0.50 against the alternative that it differed from 0.50. And it's got some questions to answer. So from that, we got some given information. We got that p hat, the sample proportion was 0.5540. We got the n was equal to 813. It told us that the null hypothesis was that p equal to 0.5, and the alternate hypothesis that p is not equal to 0.5. Let's keep in mind this is a two-sided tail test, two-tailed test. So the first thing you have to do is compute your test statistic z. And that's going to be your proportions p hat minus p over the square root of p times or minus p over n. So you go ahead and fill in your numbers. I like to do it on the calculator, and the way I like to do it is I do the denominator first. So I'll do 0.50 times 0.50. I'll enter that, and then I'll divide that by 813. Then I'll raise that to the 0.5 power. Okay, so that's my denominator. So what I could do now is I could type in my numerator, which is 0.554 minus 0.50. Put that in parentheses, and then I'll divide that by second answer. That's my denominator over there. And I get my test statistic to be 3.079 if I round to 3 decimals. So again, this was a two-tailed test. So if we look at our picture down here, we put our test statistic in at 3.079. Again, two-tailed test, so we have its symmetric. So negative 3.079 is a lower one. And we want the find the p-value is going to be the area in both these tails. So because it's symmetric, we can take 2 times the area that's in the right tail. In our calculator, we could put in normal CDF. Let's just see how we do that. So the area in the right tail is going to be second vars normal CDF. Okay, our lower bound is going to be the 3.079. Then our upper bound, we just need to pick something big enough. 10 is fine. And this is standardized Z, so 0 and 1 is by default. And when I find this area, I get 0.001. So again, let's just write that in. So this area right here was 0.001. Okay, which means this also has to be 0.001. So 2 times that, of course, is 0.02. This is my p-value. So now I have to say, well, what if I had some level of significance? So let's go ahead down here. Let's just go here. So let's say we're going to test the p-value and see if that is less than or equal to the level of significance. Oh. All right. So let's say our p-value, we just got to be 0.002, and let's say we wanted a level of significance, say, of 0.05. 0.005. So because the p-value is less than the level of significance, we will reject the null hypothesis. That p is equal to 0.5. Hope you found that helpful.